Let me explain. All right, ladies and gentlemen, so let's go through these two problems. All right, and actually, I really just want to get to this one, but let me show you this one. All right, so main important thing is when doing this, we need to break it up and say, all right, well, that pretty much means the square root of 16 times the square root of y to the 4th. So obviously, we know the square root of 16, that's 4, right? And then I say, what is the square root of y to the 4th? So what I'm saying is, what two numbers that are exactly the same give me y to the 4th? And you can say that's going to be y to the 2nd. Boom. So you can say that answer is 4y to the 2nd, right? Makes pretty good sense. OK? All right. Now let's go to this one. It's going to be the exact same thing, right? But I'm just going to kind of maybe even rewrite it a little bit differently. So rather than splitting it up, I could say, well, we have the square root of 36, and then the square root of y to the 6th. What two exact same numbers multiply that are the exact same that are going to multiply to give me y to the 6th? So what I can do, a lot of times, I like to write this like this. Y to the 3rd squared. Because when you write it like that, we know that x squared, the square root of x squared equals x, right? Because those cancel out. The cube root of x cubed equals x. Because the cube root and the cube cancel or undo each other, right? Does that make sense? OK. So a lot of times, when you're trying to find the square root, there's a little 2 right here. We're trying to find the square root. What you want to do is see if you can write whatever you have in your inner term as raised to the 2nd power. Then you just can keep on undoing, or then you can undo them. But here's where we get to a problem. Because you guys can say, all right, my answer is square root of 36 is going to be 6. And the square root of y to the 6 is just going to be y cubed, right? Correct? OK. But the main important thing that we need to look at, though, is when we take the square root of something, all right? We have an even integer, right? This number is positive. This is positive, right? Yes? But y, since it's being raised to an even power, it could be positive. This is y to the 6th. Could y be a positive or a negative number? Yes, right? But now when I take the square root of it, it's to an odd power. So what if y was negative? Let's pretend y is negative 2 in this problem. Listen. Let's pretend y is negative 2 in this problem, right? If y is negative 2 in this problem, negative 2 raised to the 6th, it's still going to be a positive answer. But now if I take the square root of it and y is negative, that's going to totally change the answer, right? Now it's going to be odd, so now this whole answer is going to be negative. So what I want you guys to understand, and this is the point, when you take the even root and you get your variable raised to an odd power, you have to now include the absolute value. OK? Because we need to make sure that this is going to be the positive value as represented before. So when you take the even root, it doesn't matter if it's to the square root, the 4th root, the 6th root. As long as you take the even root and your result, Kristen, is odd, you have to take this. You have to include the absolute value of it. OK? So now I'll get to some questions that were on your homework so you guys can check your answers.